Featured in the 2021 sci-fi novel Project Hail Mary by Andy Weir and appearing briefly in the 2026 film of the same name, the planet Erid is the mysterious homeworld of the story's alien protagonist Rocky and his species, which are referred to by humans as Iridians. Iridians are a non-humanoid sapient species at a level of technological advancement roughly proximate to that of humanity. They stand approximately half a meter tall on average and have between 4 and 5 limbs, depending on the individual, that can function as either arms or legs as circumstances dictate. The outermost layer of their bodies are covered in a rock-like mineral carapace with no obvious sensory organs, yet they are known to navigate their environment using echolocation and highly sensitive hearing. The planet Erid is a sub-Neptune just over twice the size of Earth and 8.5 times more massive. It has a surface gravity at its cloud tops of approximately 2.09 g and a mean density of 5.71 grams per cubic centimeter, consistent with it possessing a thick atmosphere and/or hydrosphere. Its atmosphere is reported to be comprised almost entirely of ammonia at a surface temperature of 210 degrees Celsius and a surface pressure 28 times that of Earth's atmosphere. While ammonia could make up a significant portion of Erid's atmosphere, it cannot comprise all of it. Ammonia is a volatile compound that is easily photodisassociated by stellar radiation, which would break the molecule apart and leave the planet's upper atmosphere dominated by its lighter constituent elements, hydrogen and nitrogen. Ammonia could therefore only exist at a level in the atmosphere below the depth at which ultraviolet light is able to penetrate. Furthermore, planets of this mass have sufficiently high gravity to hold on to the hydrogen and helium that is abundant in the protoplanetary disk from which they formed, making it even more likely that hydrogen would comprise the dominant fraction of Erid's atmosphere. The planet orbits its parent star at an average distance of 0.22 astronomical units, with a period of just 42.3 days. This is well below the bounds of its parent star's habitable zone, which lies around 0.58 AU, and so close that Erid would be tidally locked. Granted, a thick atmosphere and/or hydrosphere can, for lack of a better term, lubricate a planet's rotation and delay it becoming tidally locked. But at the distance at which we find Erid, it would have locked within 100 million years. Even if its atmosphere delayed that by a factor of 10, which is an unlikely extreme, it would still have tidally locked within 1 billion years, and the system it resides in is at least 4 billion years old. So it would definitely be tidally locked. With this linking its rotation to its orbit, Erid likely doesn't spin fast enough to generate a sufficiently powerful geomagnetic field with which to protect its atmosphere from stellar winds. At its orbital distance, the sun-facing side of Erid would receive nearly 8 times more stellar energy than Earth receives from the sun. Erid orbits the largest of the 3 stars in the 40 Eridani system, which lies approximately 16.34 light-years from Earth. 40 Eridani A, also known as Keed, is a spectral type K0.5 main sequence orange dwarf of 0.78 solar masses and 0.4 solar luminosity. It is in a wide binary pairing with 40 Eridani B and C, which orbit with a semi-major axis of around 400 astronomical units and a period of approximately 8,000 years. 40 Eridani B is a spectral type DA4 white dwarf remnant of 0.56 solar masses, while 40 Eridani C is a spectral type M4.5 main sequence red dwarf of 0.2 solar masses. Eridani B and C orbit one another with a separation of 6.9 AU and a period of 233 years. They have a combined luminosity just 2% that of the Sun, and thus do not have a measurable effect on Erid's climate. So how does Erid measure up scientifically? Its mass and mean density are consistent with a planet of that size, so plus 1 point. Its orbital characteristics are likewise well documented and dynamically accurate, plus 1 point. Erid having an atmosphere entirely composed of ammonia isn't realistic and is not likely to have the properties it is said to have. Ammonia is a greenhouse gas and would trap infrared radiation within the atmosphere. Given the high stellar flux the planet receives, it would likely be far hotter than the 483 Kelvin it is reported to be. However, it is conceivable that such an atmosphere might possess a higher albedo than what I have estimated for the planet, and this could drive down the estimate for its temperature. But that is not stated in the canon and is currently beyond my ability to estimate. That said, if Erid had the more plausible atmospheric composition dominated by hydrogen and nitrogen, with ammonia only making up less than a quarter by volume, then it is far more likely to have its reported average temperature and appear similar to its depiction in the film. But as it is, it's not feasible. -1 point. Erid is not stated to have any moons, which is unusual for such a massive planet that could potentially possess several minor moons and maybe even a couple of small major moons. But given how close it orbits to its parent star and the short hill radius it has as a result, this is fairly plausible. However, the 2026 film does show Erid orbited by a complex set of bright, inexplicably blue rings, which, while undeniably beautiful, are not at all realistic. Their brightness suggests that they are comprised primarily of ices, which is something that cannot exist even within the star's habitable zone, much less far below it where Erid orbits. And the lack of moons around Erid provides no practical source for such rings. But since these are merely a product of the film adaptation and not mentioned in the original novel, I will not subtract any points for it. Therefore, +1 point. The 40 Eridani system is a real star system with the properties described in the story, and is a good system in which to place a habitable planet that is relatively close to Earth. +1 point. With a total of 3 points, the planet Erid from Project Hail Mary receives a B grade. This is a good score for a science fiction planet and tribute to the good job its author did in building it. Its major issues stem mostly from its close proximity to its parent star, which is a consequence of it being based upon what, at the time, was believed to be a real exoplanet. But this is a prime example of why using existing planets in science fiction is dangerous. It requires authors to transmute a planet from what it actually is into what they want it to be, and unfortunately, scientific realism rarely survives the process. Thank you for joining me on this examination of the planet Erid. From here, I'll be plotting a course that takes me far outside the solar neighborhood and toward yet another strange alien world. I hope to see you there.